equations and everything, and then questions will go.
Sir, the grad was successful. In fact, he took a lot of notes to give to the students.
What?
He took our notes for the students that he got.
Oh, sure.
What did you do with the jar? The jar.
For tips. Handing out currencies, right? So the ASMS thought that I was giving it out. So they started asking me, so I had to give everything out. So currently my balance is 0. Not 0, actually, 2 fake notes.
He discovered it and he got it.
Okay, let's continue. So equations will get asked. I'll do 2 derivations. One is the velocity selected. The other one is the hall voltage. And there's one more derivation. Derivation is where consider the R equals to mv by bq. You know which equation is that, right? So এটা প্রায় জিজ্ঞেস করে। তাছাড়া আর হচ্ছে কিছু এরকম নাই। Okay, let's start with this. So number 4 is F equals to BQV. That's the equation for, what is this for? Force on a charged particle, right? And in a direction বের করার জন্য we have to use the left hand rule. So I mean left hand rule or right hand rule এগুলো হচ্ছে সব এখানে summarize করা আছে। আমি just আরেকবার দেখাই তোমাদেরকে। I was doing this with the O level batch. তোমাদেরও লাগবে। So you know the 4 rules out there. Okay, so these are the 4 rules that you have in magnetism. এর বাইরে কোনো rule নাই। So the first one is our right hand grip rule. Then you have the right hand rule. Then you have the Fleming's left hand rule, and then you have the Fleming's right hand rule. Now, when to use them? So in your A2, the most common ones are these 2. A আমি actually দেখিনি এখনো, but it's part of the syllabus. It's actually given in the textbook. It's given in the syllabus as well. That you need to know the magnetic field around a loop of wire, and loop of wire manage data. When you have a loop of wire, how does the magnetic field look around that, right? So এটা হচ্ছে এই versionটা. So first of all, right hand grip rule, এটা কিসের জন্য use করা হয়? It's to find the direction of what? Magnetic field around a current carrying conductor. Do you guys remember this one? The right hand grip rule, where your thumb is what? The direction of the current, and the fingers pointing in the direction of the magnetic field, right? And this is supposed to be a circular field. Eta 2019 এর আগেও was actually part of your syllabus in the sense that there was an equation out there. B equals to mu naught I divided by 2 pi r. So এটা বাদ দিয়ে দিয়েছে। So if you see questions on that, ওটা নাই কিন্তু, okay? That was the formula for the magnetic flux around the current carrying conductor. 2017 was when it was last there. 2017 পরে বাদ, okay? তারপরে you have the right hand rule. The right hand rule is not an official rule, if you remember, but its purpose is to do what? To find the location of the north pole around the what? Solenoid. So yeah, the solenoid, and if you want to find where the north pole is, this is what you do. This one is important. The Fleming's left-hand rule and the Fleming's right-hand rule. এখন দুইটাই লাগবে. O levels sometimes I used to say just active জানলে চলে আর তো কোনো important না, but A levels you need to know both of them. So left-hand rule কখন use করা হয়? For the motor effect, and the right-hand rule for the dynamo effect. But sometimes students don't know what the motor effect and the dynamo effect is. Doesn't know, it doesn't really help. So basically, left-hand rule is to find the direction of the force and what is provided to you, current. And the right-hand rule is to find the direction of the current, what is provided to you, force. Because motor effect tells you that you pass what through a circuit, current, and what does that produce, a force. And dynamo effect কি বলে? You apply force on a conductor, and what is induced in it, current. So induced current direction বের করার জন্য you have to use the right-hand rule, and to find the direction of the force you have to use the left-hand rule. Okay, but the left-hand rule also has an added use. What is that? It helps us find the direction of what? Yeah, the direction in which a charged particle experiences force in the magnetic field. Okay, ওটা হচ্ছে যে এটা. You know, when a charged particle enters the magnetic field, কোন দিকে bend করবে ওটা বের করার জন্য. All right. So yeah, these are there. I'll add this to your notes so that তোমাদের your reference লাগে দেখতে পারো. But A level say requirement হচ্ছে that you know this. That's why you're here. So I'll just keep this one here, okay, just for your reference. Anyways, let's get back to our equations. So there হচ্ছে syllabus এর মধ্যে what we have next. Sin theta গেল, এটা গেল. Right, so এইটার সাথে related. Number 5 হচ্ছে radius of a charge in a magnetic field. Right, can you tell me how to find this? The radius of a charge in a magnetic field, what is the formula? How do we find this? Like, how do we derive this? Derivation accordingly. Right, centripetal force is equal to the magnetic force exerted. Centripetal force হচ্ছে mv square by r, and magnetic force হচ্ছে bqv. এখানে একটা খুব ইম্পর্টেন্ট জিনিস হয় যেটা হচ্ছে আমরা যদি আচ্ছা এটা আমি পরে দেখাচ্ছি, but what can we do here? The v cancels out, and then you have r equals to mv divided by bq. Is that okay? This equation, it is খুবই useful একটা equation তোমাদের সিলেবাসের মধ্যে. But there's this other equation out there which is very underrated, but part of your syllabus, and I haven't seen enough questions on it. But আসলে না পারলে problem হবে. Momentum data. My question is, can you tell me what's the relationship between frequency and radius of circular motion, particle undergoing circular motion? Time period. Yeah, we introduced the time period here. So what's the relationship? আচ্ছা আমি কোয়েশ্চেনটা আবার বলি, কোয়েশ্চেনটা হচ্ছে what is the link between the frequency at which a particle is undergoing circular motion with its radius? So radius change হলে how does the, so let's say I'm a charged particle in a magnetic field, right? আমি enter করলাম, I'm going in spirals like that. আমি spiral in করতে পারি, আমি spiral out করতে পারি. How does my radius change affect the rate at which I'm spiraling? Proportional. আচ্ছা তোমরা একটু ট্রাই করে দেখো এটা ঠিক ডেরিভেশন, এটা 2 times আসছে as far as I know, but I think আবার আসার চান্স high. So what is the link between your radius and frequency? No, that's for planetary motion. This is a charged particle. Inversely proportional radius and frequency. তাই আসে inversely proportional. The omega. Surprising answers, but scary. Yeah. 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 ওর আগ স্টেপ পর্যন্ত ঠিক ছিল, এখানে you're doing a math mistake. কি হবে what's the link between, a simple question, what's the link between the radius of your particle and the frequency at which it oscillates? A charged particle in a magnetic field. You're not supposed to know this, you're supposed to find this. আচ্ছা, so find করার জন্য tools গুলো তোমাদের জানা আছে? Okay, এটাই মনে হচ্ছে final answer. কোনো answer? Anyone else? No? আচ্ছা, আমি বলি. This is going to be very embarrassing, but দেখে তোমাদেরকে। কি হবে এখানে? FC is equal to FB. তোমরা কি বলছো, inversely proportional না proportional? You said proportional, right? And your one is inverse. Okay, problem নাই, করি আমরা। So yeah, R equals to MV divided by BQ. Now আমাদেরকে frequency introduce করতে হবে এখানে, and we know that V equals to omega R for circular motion, right? V হচ্ছে কি হবে? Omega R divided by BQ. I don't know why this wasn't working out for you guys, but radius cancel out with that. And it's a very well-known fact in other syllabuses that frequency and radius is independent of each other. Regardless of how big the radius is, the frequency never changes. Okay? There's no relationship. That's the correct answer. Okay? So, M omega square R. Again, the R cancels out. Because on the other side, you have V equals to omega R. BQ V এর মধ্যে তো ওমেগা আর আছে একটা। সো এখান থেকে আসবে হচ্ছে BQ M times 2 pi F. So F is equal to BQ divided by 2 pi M. This formula is like famous in Excel, for example. We can হচ্ছে আমরা এই ইকুয়েশনটা দেখাতে পারি that the frequency depends solely on what factors here: how strong your magnetic field is, how much your charge is, how massive your mass is. It doesn't depend on what path you take. Okay, it cannot depend further because there's a simple logic behind this. If you go further, you definitely go faster. V equals omega R, R barle V bare. So the time that you take remains what? Same. The frequency change. Okay, this is a mathematical proof of it. That's all. Okay, so eta gelo. Next হচ্ছে এটা derivation দিতে পারে। I mean, have I done anything here that you haven't seen before? No, it's just that you couldn't simplify an equation. That's it, right? That was the main problem. Right, number 6. Number 6 হচ্ছে Hall voltage. All right, let's look into Hall voltage. So before we get into Hall voltage, can anyone give me explanation of what a Hall voltage is? Right, and that voltage is important for us for what? What reason? Yeah, it's a measure of the magnetic flux density, because magnetic flux density measure করার কোনো scientific, like, proper instrument exists করে না. So you have to make this thing called a Hall probe, and that gives you how much the strength is. Okay, so এটা কেমনে করতে হয়? Before that, we need to know the derivation. So derivation এর জন্য হচ্ছে I have seen this particular type of question multiple times. 2013, 2012 এর দিকে I remember like 2 or 3 years in a row আসলো. I'm not sure recent papers আছে নাকি। So ওরা কি করে, এরকম একটা স্ট্রাকচার দেয়, and they'll ask you questions like কোন ফেসে ফোর্স হচ্ছে, কোন ফেসে ইলেকট্রন চলে যাচ্ছে, কোন ফেসে কিছু একটা হচ্ছে, এরকম একটা কোয়েশ্চেন দেয়। Have you seen these questions? আচ্ছা, so ওইটাকে আমি বেস করে ডিরাইভ করতেছি। Okay, right, so let's say there's a conductor here, and we are applying a magnetic field across the conductor, and the magnetic field that we are applying across the conductor is an X মানে হচ্ছে into the page. Let's try to understand the science behind it, as I have a feeling যে এটা maybe তোমাদের এবার আসতে পারে। I haven't seen the most recent paper. ওইখানে যদি না থাকে তাহলে definitely আসবে। Most recent মানে হচ্ছে October, November 24. Okay, সবাই স্ক্রিনে। And this is complicated. Okay, তার জন্য একটু বুঝার চেষ্টা করো কি হচ্ছে। So this is plus and this is minus, and because of this magnetic field, as charged particles pass through this conductor, it's a metal. As charged particles pass through the conductor, typically, how is the distribution of the charged particles? Even. They're evenly spaced out like that. They're freely moving around because they're delocalized. Do you understand that? Now, once you provide a magnetic field across these particles here, we'll focus on the electrons. Electrons গুলো কোন দিকে যাচ্ছে? নিচ থেকে উপরে, so the electrons are moving that way, right? So as the electrons are moving upwards like that, can you tell me which way would they experience a force due to this magnetic field? Very correct. Left it. Magnetic field is into the page, your electron is moving upwards. Find for me the direction in which the electron experiences this force. Right. Okay, so F, B, I টা represent করে a direction in which your charge is moving. Our left hand use করলে, we have to assume our charge is what charge? A positive charge. Let's assume the positive charge is going up. Magnetic flux is which way? Into the screen. So if your charge is going up and magnetic flux is into the screen, right? It's supposed to deflect to the left. If it was what? Positive. But what is it though? Negative, right? What does that mean? That means the electrons will experience a force to the right and they'll start to move to the right. But this leads to a chain reaction. Chain reaction ki boli? As they move to the right side now becomes more negative. You know, there's more electrons are out there, and that sets up a what in this wire? An electric field. You know, আমার এখানে যখন electrons গুলো এই সাইডে চলে আসে, এই সাইডে এখন কি চার্জ হয়ে যাচ্ছে? Negative. Definitely the other side is going to be comparatively what? Positive, because you know the electrons have moved away from there. And it's a uniform structure, which means the region in between now has a what setup? Electric field. An electric field যদি set up হয়, can you tell me if there was an electron here? Let's focus on this electron here. এই ইলেকট্রনটা ম্যাগনেটিক ফিল্ডের জন্য কোন দিকে ফোর্স এক্সপেরিয়েন্স করতেছে? ম্যাগনেটিক ফিল্ডের জন্য ফোর্সটা এদিকে এক্সপেরিয়েন্স করতেছে, right? And we'll just call this force FB, okay? Magnetic force. But no, যে motor effector force. Acha. On the other side, there's going to be a force now. The electron will now experience a force on the other side. What is that force going to be? Fe is the force due to your what field? Electric field. কি হয় বলি জিনিসটা, এটা একটু প্রথমে থেকে কনফিউশন স্টার্ট হয়. So the electrons start to move this way. As they start to move this way, it produces what? An electric field. So they start to go the other way. As they're trying to go the other way, মাঝখানে একটা কি reach করে? Equilibrium. Why? The magnetic force and the electric force will become what? Equal. But ওটা reach করতে time লাগে, because sometimes students feel like, how does it happen right away? It doesn't happen right away. First, the electrons will shift, which creates difference, and that's why they'll start to go the other way. And mass connector point again, what will they experience? Equilibrium, right? And then they'll start to flow at what rate? Normal rate. But while they're flowing at the normal rate, isn't there a field generated? ওই ফিল্ডটাকে আমরা কি করি? Measure করি. আমরা যখন voltmeter connect করি, we are actually measuring the what between these two. এই যে এখানে কি electric potential generate করা হচ্ছে না, ওইটা বের করতেছি. And don't you think that this electric field must be equal to the magnetic field? And that's the reason why the voltage that we get is directly proportional to your what? Magnetic field strength. That's the reason why we can say if my voltage doubles, my magnetic field must have what? Doubled. This is the origin of it. The balancing is the origin of it, right? So how can we derive the equation for this? So equation to derive করব এই আইডিয়াটা ইউজ করে, Fe is equal to Fb, and electric field এর ফর্মুলা কি? Force. হ্যাঁ, ওটা হচ্ছে practically করতে হয়, রিয়েল লাইফে ম্যাথের জন্য দরকার নাই. So ঘুরে কেন, let's say I have a magnet here, right? It's actually a magnet, right? And I want to find the field strength of this. So আমি কি করলাম, I take my Hall probe, যেটা wireটাকে place করলাম এভাবে, and I see a voltage of 2 volts. But the problem is we get the correct answer here as long as the magnetic field is what to your wire? Perpendicular. মানে এই ডায়াগ্রামটাতে দেখো, perpendicular হওয়ার জন্যই তো আমার সবকিছু করতেছি, ফর্মুলা ডিরাইভ করতেছি. Perpendicular না হলে whatever value you get is not the accurate value. So আমি ধরো এভাবে রাখলাম, my magnet is like this, I keep it like that. My field lines are at an angle right now. আমি যে ভ্যালুটা পাচ্ছি is not the true value. So আমাকে কি করতে হবে? I have to rotate in different orientation until I get the highest value. When I get the highest value, what does that tell me? I'm what to the field? Perpendicular to the field. So এটা হচ্ছে practically আমি field line দেখতে পারি না. So আমাকে যেটা করতে হয়, I have to take a wire, I have to rotate in different orientations until I get the what value? Highest value. And that's when the formula and everything is actually working. Okay. Is current been applied to the same? Yeah, you have to connect the Hall probe to its own power supply. So there's a volt battery connected to the Hall probe. That's a separate thing. Okay. that will produce a potential difference across these 2 points like that. That's like, V equals to IR and everything. But we are finding the potential difference across which points? The sides. That's why the important term that we have to use is that the voltmeter has to be connected across the conductor. Okay, like across it, not parallel to it. Yes. It will take less than a millisecond, but it takes time, so it's not instant. But that time it takes is not something. So if you actually use the voltmeter, you'll see like it fluctuates and then stabilizes, and that fluctuation is sometimes not even noticeable, but it takes time. Yes. Right. So let's say you have a Hall probe right now, and you place it next to a magnetic field, and it tells you it's 4 volts. How much is the strength? Could be anything, right? I don't know what 4 volts means. However, I take that Hall probe and I place it next to a magnet that I'm aware of. That is 1 Tesla, and 1 Tesla gave me 1 volt. Now 4 volt means what? That process that we just did is called calibration. Calibration is basically giving meaning to the number using the setup that you are aware of, and you use that to set like a graph or something, and then rest of the place where you place it, you can use that as your reference. Okay. So all Hall probes need to be calibrated before you use them because you're making them. They're not standardized devices. Right. So what's the formula for your electric field strength? Electric force in a uniform field, VQ by D. VQ by D. Now, important হচ্ছে যে এই কোয়েশ্চেনটা জিজ্ঞেস করছিল, এখানে ওরা অনেকগুলো ডাইমেনশনস দিছিল which students got confused with. যেমন এটাকে আমরা D ডাকবো, আমরা এই গ্যাপটাকে হচ্ছে X ডাকবো, আর এই লেন্থটাকে হচ্ছে L ডাকবো. Okay, so that you know কোনটা actually matter করে এখানে. ওরা যে কোয়েশ্চেনটা দিছিল, as far as I remember, they gave all the dimensions, and that was a bit of a confusion. They put that a square, cube, and cube করলে D আর D হবে. So VQ by D, D টা কি হবে? The separation of the plates, right? Remember the thing. Now for the other side, BQV, what's the FB এর জন্য কি ইউজ করব? BQV. এই V টা কি হবে? Velocity, right? The velocity at which what is moving. The electrons are moving through a conductor. There's a name for it. Drift velocity, right? So এই velocity টা হচ্ছে at the end of the day, এটা তো ভ্যাকুয়ামে যাচ্ছে না, it's going through a conductor, so এটার স্পিডটা হচ্ছে the drift velocity. So এটা হচ্ছে drift velocity. E by Q. E by Q কোথায় ইউজ করতে চাও? F by Q is E. E by Q electric field strength charge. E by Q তো কিছু দেয় না, force দেয়. EQ, হ্যাঁ. আচ্ছা, right. So anyways, what do we do next? কি করব এখানে? We will break the V down to the transport equation, right? So ওটা কেমনে করব? Right, VQ by D. Oh, by the way, কি cancel out হয়ে যাচ্ছে এখানে? Q, which is important because হচ্ছে, students eventually will have arguments that আমরা তো ইলেকট্রনকে কনসিডার করলাম, but actually conventional current উল্টা দিকে হয়. এটা একটা সলিউশনের ভিতর দিয়ে গেলে there are ions out there which are not +1, they're +2. It doesn't matter because at the end of the day this Q cancels out. It doesn't really have an impact on your outcome. Okay, এটা আরেকটা জায়গায় cancel হয়. Do you remember where? Velocity selector. We cannot cancel out with it. The velocity selector doesn't really care what the mass of your charge is, the charge of your charge is. It only cares about the what of the charge, the velocity. So it's called the velocity selector, right? Okay, anyways, V by D is A V টা কি হবে? Yeah, it's the VH বলি আমরা, কি voltage এটা? Hall voltage, right? The potential difference across the plates. তারপর drift velocity formula কি? I equals to NAQV, so V equals to I divided by NAQ, right? So এখানে হচ্ছে NAEV, আচ্ছা এটা E লিখতে পারি, I think it's E দেয় এখানে. কেন E দেয়? Yeah, because আমাদের case we always use a watt for a Hall probe, a metallic conductor. There was this one particular paper, 2019 বা 18, where they said that it's better to use a semiconductor. Have you seen a question? 3 marks এর জন্য ছিল, কেন? Yeah, so lower n মানে হচ্ছে higher voltage মানে easy to measure. Exactly. Solution. In that case, the key has to change. You have to use whatever the ion is. Whatever. So, anyways, দেখি. Higher voltage better, lower percentage uncertainty. Easy to measure. Like 0.1 এর জায়গায় যদি 1 আসে, isn't it 10 times more like lower uncertainty? Okay, so VH is equal to VI divided by NAD times E. Now, eta key. Can anyone tell me? Can A key based on the dimensions I've provided? What is N? Sorry, what is A? Huh? LD. Naki DX. কি হবে? Wait, এখানে এসে problem হচ্ছে কেন? I equals to NA cube এর মধ্যে what is the A? The cross-sectional area of the wire through which the current is passing, right? What's the cross-section of the passage of current here? Is it this side? না তো current এদিকে যাচ্ছে না, কোন দিকে যাচ্ছে? এইটা. So isn't it supposed to be this one? So what is that going to be? XD. Still not convinced. কি হচ্ছে বলো? Problem কোথায়? XD তো হওয়ার কথা, right? So anyways, XD আসবে এখানে what cancels out? D. So which means what is not really that important here? The width of your conductor. What is very important here? The thickness of your conductor. That's why for a Hall probe, they say to use bigger width conductor, like not normal wire, borrow wire. I'll show you why. Eventually, voltage will. Well, VH is equal to what? VI divided by তোমাদের derivation ছিল NTQ, if you remember that. ওই NTQ এর মধ্যে the T is what students eventually don't realize. এটা তাহলে এখন আমাকে বলো কি হবে? The thickness, okay, not the width. That's why they use T there, okay? So এটা হচ্ছে thickness. Charge base, we use electrons here. So if you keep using the same conductor, the value is same. If you change to a solution, then it changes. Okay. So VH is BI divided by NTQ. Now, how can we increase this value? VH. Yeah, I can use high current. I can use smaller thickness here, like thinner wire resistance. Thickness thinner করতে হবে. Just a second. Thinner thickness produces higher Hall voltage. Why would that be? Sure, definitely. It's just part of the equation. It's not like we have to explain it. But enter key Hall, the charge carrier density lower. Can you give me a material that has lower charge carrier density or low charge carrier density? Semiconductors. Right. So semiconductors are tissue chilo. What was that? No. N ta fluctuate kore. N ta fluctuate kore temperature barle N bare. I'll explain what I'm trying to look for. There was this one question, and I don't remember where exactly. ওরা বলছিল যে semiconductor কে heat করলে it becomes a better conductor from your AS. Remember that temperature বাড়লে more charge carriers are released, and that makes it a better conductor. N বেড়ে যায়, right? So the question is, তাহলে তো temperature বাড়লে N বেড়ে গেলে voltage কমে যাবে. Wouldn't it be a bad thing? But there was one question. I don't know if it's Cambridge or edX, but they said it's not an issue. Why is it not an issue? So জিনিসটা যেটা হয়, তোমার nটা যদি বেড়ে যায়, এই সাইডে আরেকটা জিনিস চেঞ্জ হবে because of it. What is it? Current. And current তো বাড়বে at the same ratio because I equals to NAQB. So I যে rate বাড়বে, NO same rate বাড়বে. So eventually it doesn't really have an impact on your overall change. Okay. So questionটা কি ছিল? The question was that as the semiconductor heats up, it produces more charge carriers. why does that not change the Hall voltage? Wouldn't that be a deceptive outcome if তোমার temperature জন্য Hall voltage বেড়ে যাচ্ছে, and now you think that তোমার magnet is getting stronger, but তা হয় না কিন্তু টেম্পারেচারের জন্য তোমার দেখা যায় যে Hall voltage চেঞ্জ হয় না। কেন চেঞ্জ হয় না? Yeah, because n যেভাবে চেঞ্জ হয় I exactly same ভাবে চেঞ্জ হয়, so it doesn't really have an overall impact on it. Okay, right, this is the Hall voltage derivation. হ্যাঁ বলো। It's always safe to say charge carriers, because in gas laws as well, what do we prefer saying? Particles. We don't say molecules and atoms, right? Because scenarios can change. So if you say particles, it encompasses everything. Same way when you talk about Hall voltage, right? Charge carrier is better because we are describing our answer with the electron flow, but typically in electricity we use what flow for everything? The positive charge flow, right? So if you want to overcome that gap, just say charge carriers. It's easier. Okay, so এটা গেল Hall voltage. Our number 7 হচ্ছে velocity selector. Velocity selectorটা হচ্ছে 4 marks এর জন্য একটা question আসছিল where you have to draw the whole thing and write the whole thing. Have you seen the question? No? Acha. So there was this one particular, or have you seen velocity selector questions? It's there in the syllabus, but I don't recall seeing them in recent papers. The last time I saw was 16. 15, 16 এর দিকে একটা question আসলো যে draw the diagram and explain the working of velocity selector, the whole thing, 4 marks. হ্যাঁ, so the thing is যত gap বাড়ে তত chances বাড়ে. It's in the syllabus, they didn't get rid of it. What's the velocity selector? Which when you pass a charge through a parallel plate with magnetic field in it, the charge particle will move through it only if it has the right amount of velocity. বেশি থাকলে নিচে চলে যায়, কম থাকলে উপরে চলে যায়। ওকে, আমি এটা হচ্ছে just reference এর জন্য রাখলাম, তোমরা একটু দেখে নাও because I need to do more things here. আমি তোমাদের just একটা জিনিস এখানে অ্যাড করে রাখি। There are 4 experiments or structures that you need to have memorized, and এগুলো যদি আসে you can't make them up. মানে তোমাদেরকে একদম পুরোটা জানতে হবে ম্যাগনেসিয়াম থেকে, and প্রায় আসে। নাম্বার 1 টা হচ্ছে velocity selector, and number 2 হচ্ছে demonstrating Lenz's law. Have you seen that question? So এটা আরেকটা আসে demonstration of Lenz's law. Sorry, which one? Oh, we just use a coil, we take the magnet in the coil, and out of the coil it deflects one way, it deflects the other way. Paper 4, demonstration of Lenz's law. I mean, বের করে বলবো এটা past paper আসছিল। আর যেটা I think the one you're talking about, ওইটা হচ্ছে খুবই common and definitely আসছে in the recent papers, is to find the magnetic force, where you take a magnet and you place it on a balance and you place a wire inside it and the current passes through the wire and the reading on the balance changes, right? So এটা হচ্ছে finding F due to magnetic field. Or এটা I'm not really sure what the syllabus take on it is, but I've seen questions on it. AC current বেশি দেখি, but it's part of magnetism as well. The transformer. So transformer নিয়ে question দিতে পারে, the structure of it, the laminations, মনে আছে কোনটা laminations to reduce eddy current, right? So এই magnetism থেকে এই জিনিসগুলো হচ্ছে you have to give extra attention to. না, but question paper আছে অনেকগুলো, ওই যে তোমার ইনপুটটা আউটপুটটা যে শিফট হয়ে যায় ফেজে, সো আলাদা করে লেখা নাই। যেমন ও লেভেলসে তো থাকতো স্টেপ আপ স্টেপ ডাউন সব কিছু, ওরকম কিছু বলেন নাই। তোমাদের কিন্তু মোটরও নাই। মোটর মানে the working of a motor, split ring commutator, slip rings এগুলো নাই, তো দিতেও পারে, this is part of magnetism. I mean মোটর আমিও দেখি নাই, but ট্রান্সফর্মার কিন্তু লেখা ছিল, আমরা দিয়ে দিচ্ছি ওরা। Okay, let's move to the next topic, number 8. Number 8 is just the topic is the equation. What am I talking about? No, we won't equation. Number 7 to যেটা velocity selector, just see the yeah, v equals to মনে আছে ফর্মুলাটা bd আছে এর মধ্যে velocity selector that তুমি দেখে রাখি the disbelief on your faces, I have to show it. Millikan's oil drop experiment. I don't know. The Konoja Lakine, we have removed it. So it's just it just disappeared from the paper. Hey, not removed it. Hey, this is the velocity selector, and the equation I'm talking about this one. V equals to V divided by BD. So it's in your notes to take in. V is potential difference, and B is magnetic flux density, and D is the separation of the plates. Okay, last equation. Well, there's one more equation left in the entirety of magnetism. What is it? Yes. Well, the whole topic is basically the equation. EMF induced is equal to what? Minus N d phi by dt. What is this? এটাকে কি বলা হয়? Faraday's law of electromagnetic induction, right? Now, there are 3 layers to this equation. First of all, the EMF that you get here is the what EMF induced, right? And the second one, d phi by dt essentially means what? Rate of change, right? So that's the rate of change of magnetic flux. Rate of change. And a minus sign is its own topic. What is it? Lenz's law, right? That whatever you try to do and induce is actually trying to oppose the motion that created it in the first place, known as the Lenz's law. Now, no, just magnitude lage na, graph lage. So tomar graph jodi sine graph hoy, and জিজ্ঞেস করে what's the outcome, you have to draw like a minus sign. Our lastly হচ্ছে phi টা দেয় না কোনো সময়, ওরা কি দেয় rather b. How do you get phi তাহলে? Yeah, so phi equals to BA, so DB into বাইরে কি নিয়ে আসবা A, এটা হচ্ছে like a constant. So basically beta fluctuation তোমরা দেখি, এটা একটা গ্রাফ দিবে তোমাদেরকে, typically যা দেয় of a D, of a phi versus T graph. কারণ গ্রাফের গ্রেডিয়েন্টটা তোমাকে কি দিবে? EMF না, negative EMF দিবে, তারপর ওটা মাইনাস করতে হবে to get the actual answer. Okay, clear এটা? Right, so I mean just syllabus দেখেন if there's any other question that I've missed out. BLV, oh হ্যাঁ, এটা আমি মেনশন করতে চাইছিলাম তোমাদেরকে. There's this alternate equation out there, খুব এডএক্সেল খুব কাজে দেয়, তোমাদের এখন ওরকম কোয়েশ্চেন দেখি নাই, but know this equation, it's very handy. BLV, যারা BLV ইউজ করবা, you'll find that it'll save time. তোমরা BQV তে সরি এই যে এটা দিয়ে অ্যানসার বের করতে পারো, but this one saves time. Now what is this equation? Let me explain. এটা হচ্ছে you have a conductor that has been moved through a magnetic field and you want to find the EMF induced in the conductor. There's a shortcut here. B is the magnetic flux density, L is the watt of the conductor, length of the conductor, or V হচ্ছে the velocity of the conductor. এটা দিলে you can actually directly find the EMF induced across the conductor. It's a shortcut, এটা derive করা যায়, you can derive it from here. It can take derive করে এখানে আসা যায়. So if you can directly use this, I remember seeing a question where they used it as like or the somebody can use that as well, saves a lot of time. Okay, and that's it so far. I don't see any more other equations here. AC currents se kichu ache, but AC currents to separate chapter on its own, so we'll do that. Right. Okay, so there you go. Magnetism air shock equations, the laws out there, the definitions that we have. Now it's your turn to tell me which questions you have problem with. Well, then we'll do later. So yeah, which one? C2, this one. Okay. 1C, 3C. All right, let's have a look. It says a small solenoid of cross-sectional area this and is placed in a larger solenoid of area that. The larger solenoid compare the magnetic flux in the two solenoids. Magnetic flux in the two solenoids. Ki hobe answer? Compare korte bolche the magnetic flux in two solenoids. What should it be? Larger in the bigger one. এখানে হচ্ছে এরিয়া দেওয়া আছে, টার্নস দেওয়া আছে, সো I think 1 mark নাকি, just 1 mark. আচ্ছা আমি তাও চেক করে দেখি ওরা কি নিউমেরিক smaller to higher magnetic flux. Narrow number then, right? Acha, so this said compare the magnetic flux in two solenoids. Magnetic flux. Magnetic flux key actually. What is magnetic flux? Magnetic field lines. Okay. Now imagine there are lines here. এরকম lines দেখা যাচ্ছে and এদিকে lines দেখা যাচ্ছে এভাবে. So they're asking you compare the lines in the bigger one and smaller one. That will make a little easier for you. Can you tell me how to compare the lines? So the bigger one and the smaller one, how do you compare the number of lines? Which one has more lines? The bigger one, and the smaller one has what? Less lines in it, right? So you can just compare the magnetic flux khali. So answer ki hobe, a smaller coil has less flux inside. Reason chai nei, but reason jodi chaito tale ki hoto, the smaller coil has a smaller area. Right, next বলছে compare the magnetic flux linkage in the two solenoids. Magnetic flux linkage এর formula বলে things will be easier. What was the formula for magnetic flux linkage? BAN sin theta, or BAN, right? So flux linkage. So flux linkage equals to BAN. What plays a role here? So BA টা কি? BA টা হচ্ছে flux, right? আর linkage এর জন্য আমরা কি দিয়ে মাল্টিপ্লাই করি? N দিয়ে. So তোমার যদি n টা দুইটার তো flux হচ্ছিল শেয়ার করা হচ্ছে, but what's the number of ratio for turns? কোথায়? একটা 600 is for the larger one and smaller one is 3000. Obviously 3000 will be greater. So magnetic flux linkage is greater in the smaller one. So smaller, and I'll explain what the reason is. The smaller coil has greater flux linkage. So linkage it's like this. You have one coil here and you have one coil here. So এটার সাথে এটা লিংক হচ্ছে। এটাকে কম্পেয়ার করতে পারো উইথ স্টেপ আপ স্টেপ ডাউন ট্রান্সফরমার্স। দুইটার বি সেম থাকে, এখানে টার্ন একটা, এখানে টার্ন 10টা, তার জন্য মোর কাটিং হয় because there's a greater flux linkage here. So যেটা হয় যে you have one coil here produces one flux, right? And there's one coil here takes that flux. So linkage is 1:1. But এখানে যদি 1 থাকে আর এখানে ধরো 5 থাকে, তাহলে 1টা কিন্তু 5টার মধ্যেই লিংক হচ্ছে। So এখানে লিঙ্কেজটা বেড়ে যাচ্ছে। Linkage is basically how much of this can that receive, and having more turns means it can receive more linkage. Okay, so smaller coil has greater flux linkage since there are, there are more number of turns in the smaller coil. Density B, find এটা তো B. Okay, so তুমি যদি phi দেখো, phi different হবে. Phi কেন different হবে? A different. আচ্ছা আমি তোমাকে এভাবে দেখো। So যাদের confusion between flux linkage, flux density, এটা দেখলে বুঝবা। So আমার দুইটার জন্য হচ্ছে what must be same, the number of lines per unit area, কারণ এটার সাথেও এটার মধ্যে যাচ্ছে। Do you agree with that much? Density কিন্তু is independent of the area you're in. It's like density is independent of the size of object you're dealing with for like material density কি বড় ছোট ম্যাটার করে না তো। So এখানে কিন্তু density is same for the big coil, and density is also what for the small coil, same, because the spread of number of lines per unit area is same. So এটা পাশে দেই, B is same. However, phi is equal to what? B into phi. B is phi by A, right? So phi equals to B into A, right? তাহলে যার এরিয়া বেশি হবে তার কি বেশি হবে? Phi বেশি হবে for the same B. তার জন্য যার এরিয়া কম হবে তার phi কি হবে? কম হবে. And that's the reason why smaller coil has smaller what? Flux. খালি flux. Okay, যেখানে ওরা এই যে magnetic flux. Okay, but flux linkage যেটা কি phi into n is going to be BAN. এখানে তোমার B কি for both of them? Same. এখানে n টা is so that's why I was looking for numbers. If you look at the ratio here, what is the ratio of the area here? 1:4, I think, right? What was the ratio of turns? 600 to 3000, right? So which one has a greater emphasis here? The number of turns. তার জন্য হচ্ছে flux linkage বেশি। তোমার যদি এটা 1:4 হতো, number of turns, right? তাহলে flux linkage same হয়ে যেত, because it's balancing out phi into n, right? So এখানে হচ্ছে যেহেতু this is going up by 5 times and this is going down by how many times? 4 times. Phi n, which is what we call flux linkage, is going to be going up. So it's going to be greater. Okay, but for a reason কি is আমি একটু দেখে নিতে পারো। B because এটার কোনো B নাই কিন্তু। This is the one that's producing the magnetic field. It's just another coil in that field, so it's not producing its own field. So you're just capturing the field lines here এই জায়গাটার মধ্যে। So এটার যে spread, যে density, same should be here as well. So I'll show visually. So let's say এখানে number of lines গুলো এভাবে দেওয়া। These are magnetic field lines. Do you see how they're concentrated? So আমি যদি এটাকে continue করি, the concentration of lines, যদি আমি বের করি, the concentration of lines here and the concentration of lines there, same or different? Same. And concentration of lines কে হচ্ছে আমরা কি হিসেবে quantify করি? Okay. Right there, actually দেখেনি কি বলছে ওরা। This is no কোনো reason দেয় নাই। That's a less in small, greater in smaller, the flux linkage, আর কিছু বলে নাই। Okay, state Lenz's law for electromagnetic induction. So I think we all know this, but then we need to know how they want it. So what is Lenz's law in their words? কি হবে? The current induces such that it creates such that it opposes the motion creating it. Right. So this is the problem. ওরা হচ্ছে একটা ওয়ার্ডকে আন্ডারলাইন করছে এখানে, change না লিখলে ওরা মার্ক দিবে। আন্ডারলাইন মানে বুঝো তো, you have to have it, right? So your one was what? The induced current produces a force that opposes the motion, right? I think ওই motion থেকে change লিখতে হবে, the change in magnetic flux. So here's the thing, you don't need to have motion to create Lenz's law. Even if there's a change in magnetic flux, that also creates a Lenz's law, because that change is created, right, which induces an EMF. Your EMF will then create a force to oppose the change. So the change could be a motion, the change could be a change in flux as well. Okay, so আমি like Mars Kimura কি চাও এই আনসারটা দিচ্ছি. So Lenz's law states that, so exam যদি আসে এটা লেখো, okay, states that the induced induced current is better, or এখানে EMF লিখছে, but it should be current because EMF can't produce opposition. So state that the says that the induced EMF is such that it opposes the change So I'll clarify a few things here. States that the induced EMF এখানে হচ্ছে current দিতে পারো, but current হচ্ছে only possible if it's a complete circuit. Okay, it's such that it opposes the change creating it. This is the change. Change can be of what? Change in flux or direction of motion. Though there was another paper, যেখানে definition different ছিল, আমি দেখিনি actually. হ্যাঁ, এই Lenz's lawটা হচ্ছে consistent না, তোমাদের O levels also for 1 mark. This is a little older paper, so I'm not sure যে এটা কি এখন the accepted one or not. You have to write the formula. Yeah, so the other version যেটা ছিল direction of induced current is such that it opposes the change cause আছে change so এখানে ছিল, so just ওরা induced current allow করছিল, that's the only difference. এখানে direction টা add করলে হবে. Yes, the direction is such that it opposes the change causing it.
States that the induced current generates magnetic field that opposes the change in the motion.
Yeah, you can do that because you're basically explaining what is actually changing, which they don't, right? Okay, now your question is this one, part 2. The terminals of the smaller solenoid are connected together. The smaller solenoid is then removed from the inside of the larger solenoid with reference to magnetic fields. They explain why a force is needed to remove the smaller solenoid. Reference to right. So আমরা কি করতেছি, আমরা এখানে connect করতেছি. Did this say connect? Yes. Connect করার পরে, if I try to remove the smaller coil, I need to apply a force, like a greater force to remove it. কেউ বলতে পারবে আমাকে the basic idea কেন বেশি force লাগবে? Why? They produce an opposing force, attractive force. So আমি explain করি কি হচ্ছে, as you try to move this thing, what does the smaller coil do? The smaller coil cuts the magnetic field lines here, and in the smaller coil, what is induced? EMF. But it's a connected coil, which means what will be able to flow through it? Current. And whenever there's current flowing through a solenoid or a coil, what is produced around it? A magnetic field. But due to Lenz's law, you have to refer to that. Due to Lenz's law, that magnetic field that's generated will try to watch your motion, oppose it. So as you try to bring it, it tries to pull you back in. So you need to give more force to remove it. That's why the force is greater than what you want. Okay. The marking points here. Have a look. In these things. As long as your field lines and the coils are perpendicular, they produce EMF. I'll show you here. this one. So do you see how those white lines are being cut by the coil? Right, so basically that's happening. In this scenario, it's the other way around. We're moving the coil, not the magnet. Here we're moving the magnet. So as I move the magnet, those lines get sliced. Sorry, which one, Albert?
What is the induced EMF is formed by what?
The field lines, not field lines, the coil cutting the field lines of the original magnet or original circuit. So let me show you from scratch. So what happens here is that you have current passing through this circuit, right? As current passes through the circuit, what is generated in this circuit? Field, right? আচ্ছা সবাই একটু দিকে দেখো, I'll take this one step further. 5 mark যদি কোয়েশ্চেন হতো, আমাকে একটু বলবা যে এটা যদি প্লাস হয় আর এটা যদি মাইনাস হয়, on this side of the solenoid কি pole generate হবে? Give it a try. Then I'll understand you have understood this or not. So what pole of a magnet, north or south, is generated on this side of the coil? No, it's pulled down. How do you guys even get this answer so fast? I'm to start to করতে পারি নাই. Yes. Yes. Huh.
That means this is flowing there, it's not flowing.
Huh.
Since that's not flowing, you're pulling it up, it will kind of move.
So it'll produce a south pole. Acha, which mistake to go there? There's a mistake. So I have to figure out. It'll be not. You know? So that side is yes. Right. তোমার কারেন্টের ডিরেকশন রং ছিল। ওকে, সো কারেন্ট এদিকে যাচ্ছে, কারেন্ট এদিকে যাওয়ার পর উপরে যাচ্ছে, উপরে গিয়ে নেমে on the front face, where is the current facing? Downwards. আমরা front face থেকে follow করি, and on the front face, if your current is pointing downwards, what is the pole going to be on the left hand side? The left hand side here will generate a what pole? South pole. Okay, so এখানে একটা south হবে, and as you try to take your magnet out, you want to prevent the magnet from going out because the Lenz's law will try to oppose what you're trying to do. How can you prevent the magnet moving out if you are a north pole? By trying to attract it, right? So you can only attract it if what's induced in the other coil, south. So what will happen here is, going back to your question, as we try to take this coil out, this coil will cut the magnetic field that's already present here, and this coil will have EMF induced in it, and that EMF will produce a current, and that current will be in such a way that it generates a what pole on this side, south pole, and that opposition makes it difficult for you to move it out. ওরা বলছে magnetic flux linkage, change in magnetic flux linkage, current is না, এটা কি বলছে, two fields create an attractive force. It's a smaller one. হ্যাঁ বলো। It is clear. Okay, next, which question? Eddy current. Eddy current is not applicable here. Eddy current is the current that's produced in systems where an unwanted current makes your system inefficient. We only have eddy current in two places in our syllabus: a motor and a transformer. This is just Lenz's law. So in a transformer, what happens is the central iron core, right? Class station, in the central iron core, there is EMF induced, and that is unwanted. We didn't want it. That's why it's called an eddy current. In a motor, you're trying to spin it, but it cuts the magnetic field lines, it produces an EMF, it opposes your motion, and it slows down your motor. That's why it's called an eddy current. So those are, eddy current term is only used for scenarios where the induced current is causing efficiency loss. This one is just a demonstration. Can you call it an eddy current? Yes, but it's not really what eddy currents are normally meant for. That's what we did. Because we need to create an opposition, right? So that's what has to be done. Synonym. Oh, yeah. But it doesn't need to be একটা word use করে ওরা check-in এর সময় in the same context. So ওটাও allow করে. So যেমন হচ্ছে opposes the change that causes it. Change এর জায়গায় change in লিখলে কোনো কারণে allow করবে. It doesn't need to be like word to word that. It needs to imply the same meanings. Sorry? কোথায় মানে এখানে কি হচ্ছে? হ্যাঁ, এখানে এখানে যেটা হচ্ছে এখানে ফিল লাইন্স গুলো তো ওই বড়টার ফিল লাইন্স, আর তুমি যখন মুভ করতেছো এটা কি করে বড়টার ফিল লাইন্স গুলোকে কাট করে, রাইট? কারণ বড়টার ফিল লাইন্স এরকম আর তোমার কোয়ালিটি এরকম, ভিতরে যাচ্ছে, ইউ আর স্লাইসিং দেম ওয়ান বাই ওয়ান। So as you slice them, according to Faraday's law, if there's a rate of change of magnetic flux, what is induced? এটা কানেক্ট করলে এটা যদি ম্যাগনেটিক ফিল্ড হবে, এটা ব্যাটারি নেই তো, এটা জাস্ট একটা ওয়্যার। এখানে ব্যাটারি থাকলে থিংস উড বি ভেরি ডিফারেন্ট and complicated as well. Oh, we'd say exactly this answer, but we'll also add to it the poles, like what poles are generated. Yeah, because here the poles were not given. So mentioning the poles would give you the extra 5 marks. Okay, next one question. 3C. No, I'll do 3 questions. Tough শেষ. Define magnetic flux, B theta, C. আচ্ছা, প্রথম থেকে দেখি। A square coil of side is provided here, consists of insulated turns. Terminals গুলো এখানে দেওয়া। The coil is stationary in a uniform magnetic field. The plane of the coil is perpendicular to the magnetic field as shown here. Acha, the density is provided. Determine the magnetic flux linkage inside the coil. ঠিক আছে, calculate the এটা কি state how shows that electromotive force induced across the terminals from 0 to 60 is constant. 0 to 60 key. Are they moving it? Oh, the magnetic field strength is changing over time. That's okay. In the procedure in B is repeated, but this time the terminals of the coil are connected together. So terminals of the coil. Coilটা কিরকম দেখতে? So এদিকে ঘুরে 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 আবার ব্যাক করছে এখানে। That's what it is. So ওরা বলছে that state and explain the effect on the coil of connecting the terminals together during the change in magnetic flux density of 6 in figure 6.2. Okay, so it's similar to what we just did. The connect যদি করো তাহলে এটা ভিতরে EMF induce হবে and what will flow through it? Current. But I remember this question, there was an issue with the size of the coil. You had to mention, I think coilটা হচ্ছে circular coil যদি হয়. Okay, let's this one. Let's try with this one. Can anyone tell me if current passes through this coil, will this coil get bigger in size, smaller in size, or remain the same size? If current passes through a single loop of coil, right, will the coil get bigger in size or smaller in size, or it doesn't really matter? চিন্তা করে বল, এটা O levels এর একটা কোয়েশ্চেন থেকে আমি জিজ্ঞেস করতেছি, because I want to make sure that you get that before we start this. Smaller in size. কি opposite? Current direction opposite দেখি কি opposite হবে? Magnetic field. মানে সাইজ চেঞ্জ হবে না? কেন squashed হয়ে যাবে মানে you're saying it's going to shrink আচ্ছা circle there check really I'll refer to this and I think A levels to question দেখছিলাম we'll take it one step like lower make it easy for you so you have this wire here and eta plus eta minus what's generated around it a magnetic field right let's say you take another wire and you place it right next to it and it also produces a magnetic field এটা হচ্ছে grade 10 এর question paper আছে যে what do these wires do they attract or do they repel attract না নিউটন জন্য যা হবে সেম হবে কি হবে attract নাকি repel yes কেন attract হ্যাঁ মাঝখানে যেটা হবে যে এটা ফিল্ডটা এদিকে যাচ্ছে ওটা ফিল্ডটা ওদিকে যাচ্ছে দুইটা মিলে মাঝখানে হচ্ছিল অপোজিট ডাইরেকশনে থাকে they cancel each other out it gets weaker at the center is stronger on the outside from strong to weak একটা force exert করা হয় right if the direction of the current is in what direction same direction what happens if they're in opposite direction yeah so opposite direction হলে যেটা হয় যে তোমার ফোর্সটা হচ্ছে উল্টা দিকে চলে যায় do you get my point now এটা যদি rectangular একটা কয়েল হয় তাহলে আরো ইজি হয় because কারেন্টটা এদিকে কারেন্টটা কোন দিকে উল্টা দিকে উপরে কারেন্টটা এদিকে আর নিচেরটা এদিকে so all sides will be experiencing force which way outwards এটা outwards এটা outwards এটা outwards এটা outwards I'm not sure যে এই particular questionটা কি এটা চাচ্ছে নাকি but typically একটা কয়েলের ভিতরে যে কারেন্ট ফ্লো করে a coil is supposed to get what in size bigger in size because the forces pushes it outwards okay এখন এখানে যেটা হচ্ছে that ওরা বলছে the procedure is repeated this time with the terminals connected state and explain the effect on the coil so first you have to say the terminals are connected so because of the EMF induction what will be generated in the coil a current so there'll be a current in the coil because of the current regardless of which way the current is ওরা বলছে effect on the coil so can we find the current here FBI number the force China so yeah I feel like the size of the coil should get bigger that's the other point so 3 points এর মধ্যে হচ্ছে right outwards হওয়ার কথা inwards লেখা আচ্ছা আমি চেক করে দেব yeah so one mark which induced EMF produces current current causes a force opposite sides of the coil forced inwards no it's outwards I remember this question because দেখি মনে পড়ছে but maybe last time এই same problem আমি face করছিলাম আমরা যে inwards হবে না outwards হবে inwards কেন হবে inwards হবে if the forces are or the current is in the same direction না most likely আমরা কয়েলটা কোন দিকে ফেস করতেছে এটা তো প্রবলেম হতে পারে বলো if they're connected they're one big loop right yeah but so for it to be inwards this current and that current has to be the same direction that is not really possible right I think যেটা হচ্ছে বুঝছি okay let's try this by the way it's not that we need to write this answer there was a much easier answer out there it heats up that was the other answer right because current flow goes does when the coil heats up I think that would have been an easier way but since we took this path let's try to figure this out so আমাদের যেটা করতে হবে আমি তোমাকে একটু বলি and তোমরা একটু try করো এটা আচ্ছা I think you can figure it out on your own let's say magnetic flux wasn't changing and I was pulling this coil through the magnetic field, তাহলে কি EMF induce হবে? Again, instead of actually changing the magnetic flux, if I pull the coil through the magnetic field, would there be EMF induced? Yes, cutting of field lines, right? Tell me if this is the force and this is the magnetic flux, right? A wire term, let's call it AB. Which way would the induced current be? বের করো এটা, তাহলে it'll solve your problem. So এটার জন্য আমরা কোন হ্যান্ড ইউজ করব? Right hand. Left hand করা যাবে না because this is induced current. আজকেই করছি আচ্ছা. So FBI, F is this way, magnetic flux is into the page. Currentটা কোন দিকে যাচ্ছে? A to B. F B. হ্যাঁ না left hand করে দাও, reverse করে দেবো, A to B আসে না? হ্যাঁ ঠিক আছে. So the current is going this way. Okay, fine. Now can you tell me A wire কোথায় force act করতেছে? Let's call it CD. কোন পাশে? উল্টা দিকে? না না আমি তো ফোর্স দিচ্ছি। কোন দিকে কারেন্ট ইনডিউস হচ্ছে? কোন দিকে? সেম ডাইরেকশনে, নিচের দিকে। So আমাদের যে মিস্টেকটা হয়েছে in the previous one, we assume that the current will have a circular flow here. That can't actually happen because the changes are happening on both the wires the same way. Wouldn't they produce current in the same direction? আমরা imagine করছি যে লুপ যেহেতু হচ্ছে, it'll produce like a net flow here. But you have to understand, if I have like two wires here, let's say দুইটা wire এখানে, and there's a magnetic field there. If I move this thing like that, wouldn't the current in both of them be in the same direction? আমরা কয়েল হিসেবে ইমাজিন করছি যে এটা উপরে যাবে এটা নিচে যাবে, এটা তো পসিবল না, because the change in flux is what for both the wires? The same. So shouldn't the direction of the current be same in both the wires? আর যদি কারেন্টের ডিরেকশন সেম হয়, ধরো এটা যদি উপরের দিকে হয় আর এটা ধরো এদিকে যদি হয়, what should the forces be? Inwards, okay? হ্যাঁ, লেন্জেস লটার জন্য কারেন্ট এটা হচ্ছে উল্টাতেই হচ্ছে, আমরা তার জন্য রাইট হ্যান্ড ইউজ করছি, মানে যে কারেন্টটা হওয়ার কথা ছিল ওটা উল্টাটা হচ্ছে। It'll try to produce a magnetic flux to oppose it the other way. ওই magnetic flux এর জন্য যে কারেন্ট প্রডিউস হচ্ছে ওইটাই রাইট হ্যান্ড বের করে দেয়, সো আমরা রাইট হ্যান্ড ইউজ করছি। No, because of this current, a magnetic field is generated to oppose the motion. So force-টা কম থাকবে বা বেশি থাকবে, like previous question হবে। In the coil, and then because of that there's a magnetic field generated and that causes a force, and the force is the other way. A force is what we use in our left hand rule or right hand rule, the force we provide, not the force that the coil provides. Sorry? Oh, the interaction of magnetic field. So the coil produces its own magnetic field, and because of that there's an interaction. Yeah, and then the forces generated in the same way in the last question we did, last part. But that's the problem, নাই তো? না 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 আমি বলি, তুমি জিনিসটা কনফিউজ করে ফেলছো। আমরা যে ফোর্সটা দিচ্ছি ওইটার জন্য একটা কারেন্ট জেনারেট হচ্ছে, ইনডিউস হচ্ছে, ওই কারেন্টের জন্য একটা ফোর্স জেনারেট হচ্ছে, ওই ফোর্সটা কোন দিকে অ্যাক্ট করে? উল্টা দিকে। তো ওটা হচ্ছে এখানে, দ্যাট ডাজন্ট চেঞ্জ এনিথিং ইন আওয়ার অ্যানসার। সো এখন তোমার কোশ্চেনটা হচ্ছে আমরা যে কারেন্টটা ড্র করছি কারেন্টটা কি উল্টা হওয়ার কথা নাকি? উল্টা হবে না, বিকজ আমরা তো ইউজ করছি which hand to get our answer? Right hand, and the right hand finds the current that is supposed to be the opposite. Lenz's law কে নিয়ে তার জন্য রাইট হ্যান্ড ইউজ করা হচ্ছে, আদারওয়াইজ তো লেফট হ্যান্ড হতো। আমার উল্টা করে দেওয়া হচ্ছে না। So whenever you use the right hand, remember that you are finding which current? The induced current due to Lenz's law. ওটাকে কিন্তু আবার উল্টা করতে হয় না, বুঝছো জিনিসটা? আর ওটার জন্য কি জেনারেট হবে? একটা ফোর্স, which is not part of this question. এই কোয়েশ্চেনটা হচ্ছে আমি যখন মুভ করতেছি এটা, which way is the current? Induced current. And this induced current produces a force opposing the motion, যেটা previous question address করা হয়েছিল। এখানে it doesn't really play a role. Okay, so এখানে কি experience করবে? As you try to move the coil, you'll just find the coil is what to move. That's it, আর কিছু না। It'll shrink, and the shrinking is because of the magnetic field that produces around each wire, and that's pulling onto the coil. That's not the one that's opposing you. এটা coil-এর নিজের ব্যাপার। So আমার যদি এটা না থাকতো, let's say it was like this. I open this up, এই যে এটা কেটে দিলাম, এটা কেটে দিলাম, বলো কি এক্সপেরিয়েন্স করবো? অপোজিশন টান দিতে যাওয়া ইটস ডিফিকাল্ট, রাইট? যেহেতু এটা ইজ নট আ কমপ্লিট কয়েল, শ্রিঙ্কার হচ্ছে না, এটা জাস্ট কমপ্লিট কয়েল হওয়াতে শ্রিঙ্ক হচ্ছে, and that doesn't impact your lens's flow or anything. Clear? Yeah, because of the current. That's the easier answer. But তোমার কি বুঝছো এখন লজিকটা? Oh no, it's not moving. Because the scenario here is that the flux is changing. There's no movement there. To make it easy for you to understand why the current would be the same, I moved it because it's more intuitive. But flux change also produces a current, and flux change for this side of the wire and that side of the wire, is it same or different? So shouldn't the current be same? So you could have done that as well, but there's nothing to show flux change here. That's why I pulled it. Okay. No, if they're in the same direction, they attract. Oh, right. Yeah. They attract because I'll show you why. এখানে দিয়ে রাখছি আমি। হ্যাঁ বলো। আচ্ছা, just একটা সেকেন্ড দেখি যে that answer I'm going to show right now. এখন যদি ধরো তোমাদের এইটাই জিজ্ঞেস করে নেক্সট টাইম যে what happens to the shape of the so what happens is when you have current going in the opposite direction, right? মাঝখানে they are acting in the same direction of the field lines, so the center becomes strong and the outsides are weaker. So from strong to weak force exert করা হচ্ছে when they're in opposite direction. But if they're in the same direction, তাহলে এটার কারেন্টটা উপরের দিকে যাচ্ছে and flux এরকম, এটার flux আবার উল্টো দিকে যাচ্ছে, so the flux cancels each other out. So center now has what flux compared to the previous flux? Weaker. And from the outside to inside force will be exerted. And that happens when they're parallel and the same direction, which is the case in this scenario. Okay. In this here, or the example I showed. Yeah. So if the two wires have exactly same current and they're parallel to each other, the center will produce a null region because the field line of this goes that way and the field line of the other one is equal and opposite. They completely cancel each other out. So therefore it's a null point. A null point is basically a region of low flux. So from the strong to the low, there'll be a force exerted. Talking attraction. আচ্ছা, আমি এটা অ্যান্সারটা লিখে রাখতেছি, but yeah, we'll continue rest next class. Okay. Your mock papers are here, Daniel. Oh yeah, this is the one I was talking about. Holes and ion. Holes ছিল আগে হচ্ছে ব্যান্ড থিওরি নিয়ে, ওই যে ইলেকট্রন চলে গেলে আরো ইলেকট্রন চলে যাবে।
Sir, and if you're pulling it here, right? So that's why the current is downwards. But then
This downward current produces a magnetic field, which will oppose your motion.
And so then the force is that side, right?
The force that it's trying to exert is the other way. Yes.
So then whatever current shouldn't like current be
Current B.
downwards or something, I mean, upwards.
তোমার কনফিউশনটা বুঝছে, it's a classic example. বলি কি হয় দেখো। So let's say আমার এখানে একটা ম্যাগনেট, motor effect or generator effect এর main difference এখানে আসে। So this is the bar of magnet, and তোমার এখানে হচ্ছে you have a wire, and this is north and this is south, and this is plus and this is minus. আমাকে একটু বলো কোন দিকে হচ্ছে ফোর্স অ্যাক্ট করবে?
ভিতরে
FBI plus north to south. হ্যাঁ ঠিক আছে, একটু কি ক্লিয়ার? আচ্ছা ওকে, এখন লেটস সে আমরা কি করলাম, আমরা হচ্ছে এখানে কোনো ফ্লাক্স নাই, কিছু নাই, ওকে, আমরা ভিতরের দিকে ফোর্স দিলাম, এরকম। Can you tell me কোথায় প্লাস কোথায় মাইনাস হবে?
Now use the right hand.
না, you still use the left hand.
So there.
কোথায় প্লাস কোথায় মাইনাস হবে?
এদিকে plus হবে।
না তুমি ঠিকই করছিলে।
এই করছিলাম যে
হ্যাঁ।
near downwards, it's
হ্যাঁ।
going inside,
হ্যাঁ, সো কারেন্ট এদিকে যাচ্ছে,
right,
তাহলে এটা কি হবে?
plus.
হ্যাঁ, এটা প্লাস হবে, এটা মাইনাস হবে। বাট ডু ইউ নো, আমি যদি এখানে ফোর্স দেই অ্যাকচুয়ালি, যে কারেন্ট আমি পাবো, এটা অ্যাকচুয়ালি কোন দিকে হবে?
Minus to plus.
উল্টা দিকে হবে। মানে প্লাস টু মাইনাস হবে, বাট কারেন্টটা উল্টা হবে। আমাকে বলতে পারবে কেন উল্টা হচ্ছে?
Then just slow.
বাট কেন উল্টা হচ্ছে? লেন্স ইজ নট দ্য রিজন, বাট লাইক ওয়াই উল্টা? সো ইউ নো হোয়াটস অ্যাকচুয়ালি হ্যাপেনিং, তুমি যখন এদিকে ফোর্স দিচ্ছ, এই ওয়ারটা এই ফোর্স থেকে অপোজ করতে যাচ্ছে। অপোজ করার জন্য ও একটা নিজে থেকে কি জেনারেট করে? ফোর্স। ও যে ফোর্সটা দিচ্ছে ওটা কি ব্লু ডাইরেকশন না রেড ডাইরেকশন হবে? উল্টা দিকে। And that's the force that we normally হচ্ছে don't see. তার জন্য আমরা যখন হচ্ছে লোক এই কারেন্টটা বের করতে চাই, আমরা কি করি? আমরা হচ্ছে রাইট হ্যান্ড রুল ইউজ করি। রাইট হ্যান্ড রুলের মধ্যে আমরা দেই যে ফোর্সটা আমরা অ্যাপ্লাই করতেছি, বাট অ্যাকচুয়ালি কোন দিকে ফোর্সটা অ্যাপ্লাই করতেছি? হ্যাঁ, তার জন্য আমি যখন ডায়াগ্রামটা এখানে ড্র করে আমরা লেফট রাইট হ্যান্ড ইউজ করছি, আমরা কিন্তু জানি যে এটা অ্যাকচুয়াল ফোর্স না, অ্যাকচুয়াল ফোর্স উল্টা দিকে হচ্ছে, ওইটার জন্য উল্টা কারেন্টটা প্রডিউস হচ্ছে।
Thank you for your
আচ্ছা, describe how certain material affect the intensity reflection boundary. Yeah, এটার জন্য ছিল হচ্ছে the difference in Z is directly proportional to the reflection coefficient. The amount of reflection will be larger. The difference. Yeah, I think this is fine. Without check for the smart screen, but this should be okay. Yes. Photoelectric effect. It's a process by which electrons are emitted from metallic surface due to interaction with light. Interaction with the photon. So almost it's the process in which electrons are emitted from a metallic surface due to interaction with a packet of energy or photon. Just like, because photoelectric effect only happens when the light is in what form? Particles. Yeah. They can explain what is concluded about the universe based on the change of the phase. It's expanding as the wavelength has increased, shows the further away the stars, the faster it's. So that the universe is undergoing expansion at an accelerated rate. So it's expanding at an accelerated rate because the further they are, the faster they are. The accelerated expansion. This is the absorption spectrum, I think, right? As an atom can be raised to an excited state by absorption of photon when the white light passes through the low pressure gas form, that it is found that the absorption spectrum consists of continuous spectrum containing all the colors of the dark lines correspond exactly to the differences in the levels of the atom and the electron. Oh no, you have to mention the fact that the dark lines are produced because when the continuous spectrum passes through the gas, the electrons in the gas absorbs particular frequencies that are and those particular frequencies are then missing in the other part, and that produces the dark line. I think you didn't say that. The dark lines correspond exactly to the difference in energy levels, but why are there dark lines? Because those particular photons have been right, so they're no more available on the other side. So the way it works is you have this gas here, which is low pressure, cool gas. You're sending a continuous spectrum from there, right? What's the color available here? All of them, right? And as it passes through this, the electrons only need certain frequencies. They'll take those frequencies out, and the light then continues on its way out. When you look at the light, then you'll find that it's all the colors, but there are certain colors and frequencies missing. Those frequencies are the ones that the gas absorbs, and the electrons in the gas absorb. বলো তোমার কোনটা? বলো কোন year? 2024 February March कोई कॉल है और 2025 March. Explain how ultrasound waves are detected. An alternative voltage is applied across piezoelectric causing the vibrator to produce ultrasound waves. Oh no, you said how they're produced. So they said how to detect. How do you detect them? The ultrasound waves come and hit the crystal, causes the crystals to vibrate, and causes compressions and rarefactions or change in size of the crystal. Yeah, 3 marks. So you have to say the crystals get smaller and bigger, and as they get smaller and bigger, what do they generate across them? And that PD then tells us the presence of the ultrasound. So you have to mention piezoelectric crystal, you have to mention the fact that they vibrate, but you have to mention also that they generate a what across them. A PD, which is proportional to what the waves come in. That's how we know how the wave is there. February, March 24. February, March, right? Right, which question? First one.
Absorption spectrum. So why do we have to write this line? When Marcy I did this question last time. A dark line to occur because the photon
Absorbed, right?
Why do we have to write when the photon when the electron comes down, the photons are released again in all directions? Like why does this in all directions like this thing matter?
Yeah, so
this was a specific marking point.
Right. So do you remember why the sun's light has dark lines in it, even though the sun eventually emits all those colors out? So the electrons get absorbed, right? The electrons absorb energy, they go up. When they go down, don't they give the light back? So the dark lines shouldn't exist because you're getting the color back, right? But the dark lines do exist. Why is that so? Well, you know the reason? When absorption spectrum takes place, right? The electrons absorb certain frequencies, right? And the electrons go up. But then when they come back down, don't they give the light back out again? So shouldn't there be no dark lines because those dark line frequencies are returned back to us again? So when you're looking at the star and those lights are coming towards you, right? The absorption and re-emission causes the light not to come back to you. It goes everywhere. So the intensity that's coming to you is actually lower. And that's why they appear darker, not black. So there's some light coming in, but the rest of the light has gone everywhere else, right? Yeah. Planet may be assumed to be uniform gravitational potential uniform sphere. Its gravitational from the center is provided here. Show that the mass of the planet and this which you have like
mass.
Oh, mass.
So এখানে ওরা কেন জানি 1.5 ইউজ করতেছে
1.5
মানে এটা করে অ্যানসার আসে আর গুলোতে আসবে
না সবগুলোতে আসবে
সবগুলো 9
তাই just 1.5 দিতে আসে
I tried doing like gradient equation
হ্যাঁ
just using the equation
হয় না but 0,0 তো তার মানে তো আচ্ছা আমি check with it. That's interesting. 1 by r and phi. So তোমরা কি use করছো? Phi equals to gm by r. Then and m is phi into r. মানে phi into r divided by that's strange. যদি আসলে হচ্ছে